Welcome to Show New channel. Please don't forget to like, share and subscribe to my channel. And my today topic is about acid and base. And in first we will see the definition of organic acid and base. Organic acids are those acid which are obtained from plant and animals. So examples are lactic acid, oxalic acid, acetic acid, but we have also seen acid in form of minerals. So minerals examples are sulfuric acid and phosphoric acid. Now, an organic base is an organic compound which act as a base. They usually contain nitrogen atoms which can easily be protonated. Amines and nitrogen containing heterocyclic compound are organic bases. Example include pyridine and alkylamines such as methylamines. So there are many concepts so that we can easily distinguish between acid and bases. So first is Arrhenius concept of acid and bases. Acid is a substance which produces hydrogen ions, that is H plus, in aqueous solution. Example HCl, where you can see H plus Cl minus. And second example is sulfuric acid, H2SO4, 2H plus SO4 2 minus. So you can see here that H plus is produced in case of HCl and 2H plus in case of sulfuric acid. Now in base is a substance which produce hydroxide ions, that is OH minus, in aqueous solution. Example sodium hydroxide and ammonium hydroxide. And in sodium hydroxide you know that it is NaOH. So it is OH which is present in sodium hydroxide. So by this according to Arrhenius concept, base is a substance which produces hydroxide ions, OH minus. So this is example of once again of nitric acid, HNO3, in aqueous solution it produces H plus and NO3 minus. And Arrhenius base which donates OH to the solution and NOH in it form Na plus and OH minus. But after Arrhenius concept, there was a new concept which distinguish acids and base, Bronsted-Lowry concept. So according to him, an acid is a molecule or ions which is capable of donating a proton. So acid proton donor, you can see HCl, H plus, it donates its plus, that is proton, in form of H plus and Cl minus. While according to him, a base is a molecule or ion which is capable of accepting a proton. So in NS3, when it is accepting a proton to form NH4, which is aqueous in nature. So after Bronsted, there was a new concept which is the latest concept, and it is a well accepted concept of acid and base. And according to Lewis, an acid is a substance which can accept an electron. So example are boron fluoride and carbon dioxide. And base is a substance which can produce an electron. Example fluoride and chloride. And he has distinguished Lewis base and Lewis acid. So according to him, Lewis base, something that complexes with Lewis acid. How it is complexes with Lewis acid? Let's see. First of all, Lewis base has lone pair donor, Bronsted bases, nucleophiles, ligands, anionic counterions, electron-rich pi system. And you can easily summarize this Lewis base as highest occupied molecular orbits. And the counterpart of that is Lewis acid, which complexes Lewis base. So if it is a lone pair donor, then it is an acceptor. If it is Bronsted bases and it is a metal cations, you can see HO minus and here Al3 plus. And electrophiles, this is nucleophile, so it is a electrophiles. This is complexes. This is ligands, it produces a lot of ligands. This is the proton, and it is cationic spectator ions, and it was in Lewis basis it was anionic counter ions. So, and it has electron poor pi system, and for the whole it is in Lewis base it was highest occupied molecular orbit. In Lewis acid it is lowest unoccupied molecular orbit. So let's see how three models are related to each other and how they got evolved. So first in 1884 we have just now seen how Arrhenius model in which we have seen where acid give H plus and base give OH in aqueous or H2O. So we have considered this as a initial model, and after that there was a new model which is Bronsted-Lowry model, which suggested that acid give protons H plus and base takes proton in liquid, gas and solid, and the whole both model, Arrhenius model and Bronsted-Lowry model come under Lewis acid, which have solved all misconception regarding acid and base by explaining how acid and base are different and how they are complex with each other by this their acid and base behavior. So according to Lewis acid, acid accept electron pair and base donates electron pair. So acid accept electrons pair and base donate electrons pair. So this is this model is in 1938. So it is include both and very important. So all theory I hope you understand. Arrhenius concept, Bronsted-Lowry concept, and Lewis concept. So now see some important acids and their presence, which are very important in exam. Many times you can see this such questions like which acid is present in vinegar, red ants, citrus fruit. So here is answer. Acetic acid is present in vinegar, formic acid is present in red ants, citric acid is present in citrus fruits, lactic acid is present in curd, ascorbic acid is present in amla, tartaric acid is present in grapes, ripe mangoes, and oxalic acid is present in spinach. And there are many. So this is all our example which are very common but very interesting to know how they are present. So how to measure this acidic or base? So there is a scale which is popularly known as pH scale, and pH value is a measure of the acidity or basicity of an aqueous solution. You can see this example, and even this it is very important for exam point of view. And you can see here it is 7.4 for blood, What exactly this number? Let's see. So according to pH scale, if the solution is less than 7, then solution is acidic. And when the solution value greater than 7, then the solutions are base. So this above of 7, this is 7, are all base, and below this urine, black coffee, these all are acidic in nature. So this example, I have already told you blood is of 7.4 and tear 7.4, saliva 6.5, 7.5, your coffee, beer. So all are acid, beer, wine, vinegar 2.4, 3.4, acetic acid. So how it is very important to remember this value because I have seen in many exams these questions are asked what are the pH value of saliva or blood. So try to remember those value. Now we will see buffer solution. Buffer solution, the solution which resists the change in its pH value on an addition of small amount of acid or base, are called buffer solution. So it's resist the change in its pH value. So in if acidic buffer solution has a pH value less than 7, so for a basic buffer it would be greater than 7. pH value will be greater than 7. So pH value of blood is maintained with the help of S2CO3 or HCO3 buffer in spite of many acidic food we eat. So now you knowing that why even after eating lot of acidic food like vinegar, beer, so how you maintain your pH value of blood to basic in nature. So this is very helpful in maintaining those things. Now what is salt then? So salt, when acidic and basic solutions are mixed in proper proportion, then their own nature is destroyed. Their own nature is destroyed and a new salt is formed. So you have done this in your school's practical also, that if a solution is acidic in nature and you have dipped your litmus paper in it, so you have found that litmus paper turn into red color. If it is blue, then it will turn into red. If it is red, it will remain in red color. So, and in base, it always turn into blue color. So this is the another way to check whether it is an acid or base by checking litmus test. So if the formation of salt after mixing bases and acidic is called a neutralization reaction. So I hope you have understood the whole concept of acid and base, and thank you for listening. Thanks.